Welcome back everyone to this lecture on creating the session for our manual neural network. Now that the graph has all the nodes in place, what we need to do is make sure we execute all those node operations, including those variables and placeholders, within the session in the correct order. What we're going to do is use a post-order tree traversal to make sure we execute the nodes in that correct order. Now, as far as the way the actual post-order traversal works, you don't really need to worry about those details. We'll never really encounter this again throughout the rest of the course, so I'm just going to copy and paste this function from the notes. You can feel free to check out the Wikipedia page on tree traversal. It has the full step-by-step outline of how post-order tree traversal works, but for now, we're just going to copy and paste that function. Then we're going to manually code out the session class. Let's head to the notebook. Alright, back in the notebook here, I'm just going to copy and paste from the notes provided the post-order traversal. And basically what this does is just a post-order makes sure that we execute the computations in the correct order. So for instance, we need to execute a times x first, and then after that we can do ax plus b. So all this does is it kind of does this recursive function, and it ends up returning a list of all those nodes in their correct order. So I'm just going to run this. Again, the details of this, you really don't need to concern yourself with them. Instead, what we're going to do is essentially treat this as something that takes in the operation and it makes sure that they're all executed in the correct order. So once we have that general understanding of what that function is doing, we can create our session class. So let's go ahead and create a method in this session class called run. We'll say self operation, and then we're going to have a feed dictionary, which is the same terminology used in TensorFlow. So the operation itself is going to be the operation to compute, and then the feed dictionary is a dictionary mapping placeholders to input values. Remember, right now in our graph, we only actually have values for those variables. That was that 10 and that 1 from earlier. The placeholders are still waiting for you to provide them a value, and we're going to use the feed dictionary to provide that value. The reason we're doing it with a feed dictionary is because later on we're going to be feeding our network batches of data. So we're going to be kind of feeding it a batch through that dictionary. So we're going to say the nodes post order is equal to a call to that traverse post order function, and we pass in that operation. So we're going to say for node in nodes post order, we'll do the following checks. We'll say, hey, if the type of node is equal to a placeholder node, then I need that node output to be equal to feed dictionary key with that node. Else, if the type of node is a variable node, then I should already have that value, so that node output is going to be equal to that node value. Otherwise, if it's not a placeholder and if it's not a variable, that means I have an operation. So else, for the operation, I'll say the node inputs are equal to, and here I'm going to use list comprehension, we'll say input node dot output for input node in node dot input node. Whoops. Let's make sure that's correct. Let me zoom out one level so we can see this whole thing. So I'm saying, okay, if this is not a placeholder and it's not a variable, then otherwise I have an operation. So for this operation, I need to make sure my inputs are in order. So I'll say node.inputs is going to be equal to the output of that input node for every input node in node.input nodes. There we go. Make sure that last one's plural so it lines up with that attribute we created earlier. Then I'm going to say that the output of that node is just going to be compute that operation. So node.inputs. And you may be wondering what this asterisk is here for. So this asterisk is essentially just an args asterisk. And it's just a way for us to provide these inputs without knowing how many inputs we may have throughout the operation. So technically we don't really know the size of this list. So when we pass it into compute, we're going to just say asterisk node inputs. Now granted, all the operations we've done so far, if we scroll back up, really only expect 2 arguments. So these compute methods are really only expecting 2 parameters here, but hey, maybe we have another addition operation that adds 3 together or something like that. So since we technically don't know beforehand how many parameters we're going to pass in, we're going to use this asterisk for args. When I'm saying args, it's ARGS. And you can check out the resource link for more details on that. Finally, we'll say if the type is node output is equal to list, then I'm just going to say node output is equal to, np array node.output. So that's going to convert the list to NumPy arrays. And then finally, off of this method, I'm going to say return the operation output. So return the requested node value. Let me make sure I did everything correct. Else type node is equal to variable. Let's make sure I have that. This should be elif, not else. There we go. Okay, so perfect. We have our check for a placeholder, in which case we give it the feed dictionary value. If it's a variable, in that case we give it the actual value of that variable. So if we kind of check back to variable, come back up here, remember that variable had this kind of initial value here. So self.value of that variable, that's what we're talking about when we say node.value here. If it's not, then it's an operation. If it's not a placeholder or a variable, so then we have our inputs to the operation and our outputs to the operation. The output is just a result of computing the inputs, where the input is just a list of those node.input nodes. Okay, so let's go ahead and actually execute this. So we'll say ses is equal to an instance of a session, and then we're going to say results is equal to ses.run. And notice here I have an operation and a feed dictionary, so we're going to say operation is equal to z. Because remember, our operation all the way at the end is this final one where we add y and b. And y is then connected to multiply, which is then connected to the placeholders and the variables. So coming back down here, I'm going to provide a feed dictionary. And the dictionary is going to say x is 10. So we run that, we check our results, and we get back 101. So if we remember our original function that we're trying to compute, it's z is equal to ax plus b. So z is equal to 10x plus 1. If I provide x is equal to 10, that's 10 times 10 is 100, plus 1 is 101. We come back down here, we get back 101. So it looks like we successfully did it. Let's go ahead and show this with some matrix multiplication, which is kind of a little more in common with what we're going to be doing with TensorFlow. So starting this all over from the top, I create a graph object. Then I'm going to set that as the default graph. I'm going to have some variable, and in this case, I'm going to have the variable be essentially a matrix, so 1020, say 3040. So we just have it be a nested list for now. Later on, TensorFlow will be passing in NumPy arrays, and then we have 1, 1. Check your brackets here. Then we have a placeholder awaiting x, and then we'll say y instead of equal to multiply is a matrix multiplication now with a of x, and then we'll say z is equal to add y and b. So now if I do the same thing as before, I create a new session, and then I say run the operation equal to that new z operation is created, and we'll say feed dictionary is now equal to, we can do 10 as before, and we get back an array. So essentially kind of the same operations we did before, except now it's based off a matrix. So you can also change this to 1, 1 so it matches the notes. And you should see 101, 201, 301, 401. Perfect. All right, so that's the very basics of how a session is going to work. So up next, what we're going to do is convert this to kind of a more traditional classification problem by putting in an activation function and then doing a really simple classification example. We'll create some blobs, and then we're going to classify them into two classes, 0 or 1, red or blue, and we're going to define a Perceptron type model. All right, so that's it as far as the very basics of creating your own graph and your own session. Session may be a little confusing at first, so definitely check the time or take the time to kind of go through each of these lines. And it may be a little confusing because you kind of forget where these attributes actually are. So if there's an attribute you don't recognize, go ahead and come back up to the classes where we define them and then see what they're actually referring to. All right, thanks everyone, and I'll see you at the next lecture.